So today we will be seeing what? We will be seeing a little bit about sequence detector. So somewhere I feel actually I have made some mistake due to which you guys were not able to understand. So sequence detector today we are going to start. Okay. So sequence detector, as you know, there are basically two types of sequence detector. Okay. Two types of sequence detector. So one is what? It is your overlap sequence detector. Another is non-overlapping sequence detector. Now, what do we mean by overlap and non-overlap? So, in overlapping sequence detector, I can use the bit of previously detected or previously detected or checked sequence, or you can simply write of the previous sequence. You can use the bit of previous sequence to make new sequences. Okay, to make new sequences. Whereas over here, we cannot use the bit of previous sequences. Bit of previous sequences cannot be used to make new sequence. Okay, so this is what this two we have. Okay, sequence detector, basically what we have, that overlap and non-overlap. In overlap we can use the bit of the previous sequence to make new sequences. In non-overlap we cannot actually use the bit of previous sequences to make new sequences. Now let us understand with the help of an example. Okay, so if suppose I have my input sequence. So input sequence, if suppose we have, if this is my input sequence, okay, this is my input sequence, and same here also we will have the same input sequence. Okay, here also we have the same input sequence. So if you want to know basically more about this sequence detector, there is one book, Thomas L. Floyd. Okay, so everything that I am telling actually you can see it from Thomas L. Floyd. Same thing you will be getting. Okay, so if this is my input, if suppose, and the sequence I want to detect is what it is, let us assume 1011, like this. So I have told you what, so first start from here. So you can see in the first 5 you are getting the sequence, so output will be 1. Okay, then you start from here to here, you are not getting, so this will be 0. So once again you check from here to here, you will be getting 0. Next 5, so you are getting 1. From here to here you will be getting 0. Again from here to here you will be getting 1. So you will be getting 1 3 times. Where, so if I write properly, so once you will be getting over here, one more time over here, and one more time over here. So you can see basically the first time we have the 1, it is overlapping with this one. Okay, second time you are getting 1, again you are overlapping over here, and third time also you are overlapping. So 3 times you are getting 1. Okay, 3 times you are getting 1. So this is the shortcut way in which you can determine how many times the output will be 1. But if you want to do the proper steps, then how is it going to be detected? Look very carefully. So this actually I told you, okay? I have already explained this. Now look what happens. So we start from over here, okay? We start from this bit. So when this bit enters the sequence detector, you can see it is only 1. So output will be what? Output will be 0. It will be 0 when this sequence is not detected. Sequence when it is not detected, and output will be 1 when sequence is detected. Okay. So at the first bit, when this first bit enters the sequence detector, output will be 0. If the second bit also enters the sequence detector, you can see still it is 1 1, so output will be 0. In the third bit, it will be 1 1 0, so output will be 0. In the fourth bit, we are at this point, so it will be 1 1 0 1, so still 0. And in the last, this point, when all these 5 bits have entered the sequence detector, what will happen? You can see the complete sequence has been detected, so output will be 1. So now what will happen? Once again, your sequence detector will now start from here. So you can see this will be what now? In the next time, already you can see, listen very carefully. In the sequence detector, as this is overlap, so you can see what? Already out of this 5 bit, up to this point, everything is entered. Now I will be checking for the next bit. So we had checked up to this point for the first cycle. Now I am going to check up to this much point. So you can see 1 0 1 1 0. So this is not my sequence. So I will be writing what? I will be writing 0 after this. For this 5, 0. So the next 5 will be this one. Okay. So for this also I will be getting 0. Okay. This 5. For the next 5, you can see I will be getting 1. Okay. Next 5, you will be getting 0. For the next 5, once again you will be getting 0. For the next 5, once again you are getting 1, and you will stop your counting over here because there are no more bits over here. So you can still see that the number of times output is 1. It is equal to how many times? It is equal to 3 times. Still you are getting the same answer. Okay. So any way you want to perform, you can do it. This is a long method, but this is the systematic way of calculating, and this is the simplest method. Now look over here in non-overlapping method. So in non-overlapping method, basically you cannot use the previous bits. Once the sequence is detected, you cannot use the previous bit. Now the clear-cut simplest way of doing is that in the given input sequence, try to find out where all places you will be getting the sequences. So the shortcut way that I had told you, so you can see at this point you can get one of the sequence. Now you cannot use this 5 bit anymore. Okay, you cannot use. So the next bit, it is 0. So our sequence should start from 1. So this is not required. Once again, you can see over here you will be getting the sequence. So number of times output is going to be 1. It is what? It is 2 times. So directly you can calculate it like this. Or if you want to do systematically like this, tell me first, up to this point, is it clear? Up to this point, whatever I told, is this clear? Is this clear? Piyush, is this clear to you? Piyush, means you only told me. Fine. So now see, this was the simplest way in which you can calculate the sequence for a non-overlap detector. So now see, systematically, if you want to do once again, so how are you going to do? So look, when the first bit enters the input, so you can see the sequence is not completed, so output will be 0. In the next case also, you can see it is 1 1, so output will be 0. In the next case, this will be 3, still output 0. Over here, once again, you can see 1101 has entered the sequence detector. So this is not the sequence, so this will be 0. In the fifth case, you can see the complete sequence is present, so output is going to be 1. So now you will not consider this much bit in further calculation. You are not going to consider this. Now look over here, what is going to happen in the next step. Okay, next step, what is going to happen. So now when you see, this is 0. Okay, this is 0. So when actually 0 enters the sequence, now once again the sequence detector will start from the beginning. Okay, it will start from the beginning, and whenever you can see this is means in the sequence that needs to be detected, here it is 1, but here it is 0. So that means I cannot start my sequence counting, so this output will be 0. So go to the next bit. Okay, so next bit has already entered. So you can see now, this is the first bit of the sequence that is being detected of this one. Okay, so first bit is 1, but here this complete bit sequence, when it is detected, output will be 1 at that time. Not when you just get the 1, means this first one, when you get the first one, your output will be 1. No, when this entire sequence you get, then your output will be 1. So when you get this first one, output is 0. Now you have got this first one, your detector will check if the second bit is 1. Once again, you can see the second bit is 1, but this sequence has yet not been generated, so that is why output is 0. Now sequence detector will check for the third bit. It is also same as the third bit of the sequence, but yet complete sequence has not been generated, so still it will be 0. Checking the fourth bit, complete sequence is not detected, so this will be 0. Now at the fifth bit, you can see that basically this is the sequence, so our output will be 1, and in this case you can see the number of output is 2. So whichever way you want to solve, you will get the number of ones as same only, whichever method you solve. Tell me if this is clear or not first. Is this clear how to detect? Is this clear? Any doubt, Piyush, you have? Fine. Now let us try to see how to basically construct such type of sequence detector. Okay. So there are two ways. Or two finite state machine or two models that we can use. The first model is what? It is your Murray model. Okay. Murray model we have. Okay. So in the Murray model, we are going to see basically two of the cases. First case will be overlapping case, second case will be non-overlapping case. So first, you should remember that in Murray model type of finite state machine or sequence detector, your output is just function of the present state. Okay, it is just the function of present state, or in textbook it might be written sometimes current state also. Okay, whichever you want to say. So output is actually your present state or your current state. And one more thing over here, see, basically you need to, if suppose you have this sequence, now how is your model going to know this particular sequence has been achieved? Okay, how is it going to know? There should be some kind of state that particularly describes that when you get the first one, you go to, actually you will be checking if in the next case there are two ones. Now if in the next case, if you get after 2 1 a 0, so you are going to this state. Now after this, if you go to, like if you get the next one, so your sequence will go over here. Now after this, if you get one more one, so your sequence will be completed and output will be equal to 1. So basically your machine should be able to know that this is the sequence. So how can we construct that? So we will be constructing that with the help of the states. Okay, there are specific states over here. So remember, in Moore model, the number of states is equal to number of bits in the sequence plus 1. Okay, number of bits in the sequence plus 1. So here I will be constructing this 1101 only. So you can see the number of bits are 1, 2, 3, 4, 5. So it will be 5 plus 1. Okay, so in total that will be 6. So there will be 6 number of states. Now what are the states? So first let us name the states. Okay, name the states. Okay, first tell me, for if I have to have 6 states, what should be the minimum number of flip-flops required, or the minimum number of states? Minimum number of states required is 6. So how can we get 6 number of distinct states? Using 3 flip-flop. Very good. Because 6 states if we have, so okay, first let me give the state number. Let me show you. So the first state will be what? It will be, don't tell like, sir, we can write it like A, B, C, D. No, it is not required. Okay. The most simpler approach is what? The first state, remember in Moore model, it will be idle. First state is idle. The second state, it will be in the first, look over here, 1001. So when you get this first bit in the sequence, so that will be S1. Next state will be once you have got this one, and once again you are getting this second one. So it will be S11. So third state will be similarly when you have 2 1 present and the next bit in the sequence you get 0. Similarly, the fourth state will be S110. You have this, then you get 1. And the fifth state will be what? It will be S11011. So in total, you can see there are 6 states. So now this 6 state, basically they are alphanumeric code. So if I want to basically write them in digital, I can encode this ideal as 000, this S1 as 001, this S1 as 010, this 110 as 011, this as 100, and this as 101. So in binary numbers, I can code it like this, but it is not required. Okay, it is not required because such complex means they in GATE exam, it is never going to be asked that you need to model this. It will be never asked because it is very time consuming. Okay, so in GATE exam, basically every time they are going to ask you to detect the sequence. That's it. They will never ask you to design one sequence detector, but still I am showing you. So this is okay. Let it be written over here. So now these are the states I have. So can you draw the state diagram for this one? State diagram. How to draw the state diagram for this particular cases? Can you draw it? So just give it a try first. Give it a try. How are you going to do this? How are we going to do? So basically this is what, this is your, up to this point everything is same for overlap and non-overlap. Okay. So how are we going to draw the overlapping state diagram? So look, state diagram, next is state diagram. So if we have to see the state diagram, so first you are going to start from the ideal state, idle state. Okay, that what does this idle state signify? That you are basically in a sequence, in a random sequence. Let it be 0 1 0 1 1 0 1 0 0 1, any sequence it can be. Okay, so from whichever place the sequence is starting, you are in the ideal state. Why? Because you are searching for this first one. So before you get this first one, your flip-flop should be in some state. So that state is actually known as your ideal state. So you are in the ideal state first. So remember this sequence. So when you are at ideal state, the moment you get the first one from ideal state, you will go to S1. Okay, here you can see that this is S1. And when will you go there? When your input is 1. So remember, always I will be writing like this, input, and here it will be output. So when input is 1, if in the ideal state you are, and if your input is 1, so what will happen? You will be getting this first one, but will your output be 0? Output will not be 0 because, output will not be 1. Why? Your output will be 1 when you get this complete sequence, but at the moment you have just got this first one. So output is 0. Now, if you are at S1 state and if you get the second one, so what will happen? If your input is 1, you will be going to S2, S2 I am writing, S11, okay, S11, but still you have got this 2 bit in the sequence, but the complete sequence has not been achieved yet. So output will be 0. Similarly, if you get 0 over here, output is still not achieved, but you will be reaching at S110. So now if you get one more one, your sequence is not yet reached, you will be going to S1101. Now if suppose you get one more one, you can see you are reaching S11011. So you have reached the sequence. So now this time your output is going to be 1. Tell me if this is clear to you or not. Is this clear up to this point? So we have completed this sequence. Okay, we have completed this sequence. First tell me up to this point, is it clear? Is it clear? Everyone? So note it down very quickly up to this point, whatever I have written. So this state diagram is not completed. Why? Because I have straightforwardly just made this thing, constructed the sequence diagram. Okay, so it is not necessary that every time I will be getting this sequence. Okay, so sometimes after 1 1 0 I might get a 0, or after 1 only I get 0, or after 1 1 0 I get 1, and after that I get 0. So all those cases need to be actually implemented in this state diagram. So is this completed? So now look, what happens if we are in the ideal state? Okay, we are in the ideal state and we get a 0. Okay, something like this. So we are in the ideal state, we get a 0. So we will still remain at the ideal state only. So if we get a 0, we are going to stay at 0 only and output will be still 0. So you can see I have already constructed when we are at idle and we get input as 1, that we have already done. So from idle state, input can be either 0 or 1. So both the cases I have taken. So now see at S1. At S1, I have already taken the case for input 1. But what happens if input is 0? So that means if from 1, the first bit of the sequence is 1, after that I get 0. So what will happen? Once again, I will be going to your idle state. I will be searching for this first, means in this bit. As I got the first one, after that I got 0. So now once again, I will be searching for this first one. Okay. So I will be going to idle state once again. And output will be 0. So for S1 also I have constructed then that when it is input is 1 or when input is 0, constructed. Now come to S11. So here I have taken 0. What happens if after this 2-bit I get one more 1? Okay, after 2-bit, this 2 has already been achieved over here. You can see it is S11. So I am at this 2-bit, but after this, instead of getting a 0, I got 1. So you can see, as this is your overlapping sequence detector, so I can take this previous one to make this as 1 1. So what will happen if I get 1 over here? I will be at this state only, and output is still going to be 0. So if after S11, so S11 actually corresponds to the sequence that you have got 1 1, and once again if your input is 1, so you are seeing that you are at the starting 2-bit of the sequence, so that is why you are staying at S11 only. Now see at S10. So I will be erasing all this. If suppose you have achieved 1 0 1 in the sequence, now in the next bit if you get 1, you are going to S1101. If you are getting 0, so now where are you going? You can see, even if you take this bit or this 3-bit, you are not able to get the sequence. So you need to once again go back to the idle state and search for the first one. You need to search for the first one. So this will be 0, this will be 0. Now come over here, come over here. So you can see over here that if you have achieved 1 1 0 1, and if your next bit is 1, you are achieving this thing. What? You are achieving the sequence. But if your next bit is 0, okay, if your next bit is 0, so what will happen? You can see over here that if your next bit is 0, if you take this bit, this 3-bit or this 2-bit, you are not getting the sequence anywhere. Okay, you are not getting the starting of sequence. That means once again you have to go back to idle once again. So this will be 0, 0. Okay, tell me, up to this point, is it clear? Now will be the important part. Now it will be the important part. So see, is this clear? Up to this point, is it clear to all of you? Piyush, Raju? See, now the last case. See, we haven't discussed what will happen in overlapping case if I get this sequence. Okay, if I get this sequence and if I get a 0, so this is your completed sequence. Now if you get 0 after this, you can see that you are going to this 3 state. This is again repetitive in this sequence. So that means what? If you get 0 after this state, you are going to this state. So let me use some different color. If you get input as 0, you will be going to this state, but your output, it will not be 1. Why? Because you have just achieved the first 3-bit of the sequence. You haven't achieved the complete bit sequence. So this will be 0. What happens if your bit sequence is completed and you get 1? So you can see that this 2-bit, it is the same of the starting of the sequence detector. So you will be actually reaching, means I don't have space over here. So what I can do, I am using red color, but you basically take it from here only. Okay. So you can see this will be what? So over here I got 1 and this is 0. So tell me, is this complete state diagram understood by you or not? Understood or not understood? So this is your state diagram. Everyone tell me. So this is the complete state diagram. Tell me if this is clear or not. Fine. Now we have to draw what? We have to draw the state table. Okay, state table. So state table I am going to draw with the help of state diagram. State table. So basically I am over here, I am not encoding any of the state like idle as 00, S1 as 001. All those things I am not doing because I don't want to design the sequence detector over here. Simple thing is that I just want to show you how to draw the state table for this particular state diagram. So look over here. So first let me draw, okay, because I might make some mistake. So first let me draw. So this will be serial number, present state or current state, whatever you want to write. So over here you can write the input also, okay, input, or fine, input we can write over here, or it's okay, let me do it in the single table only. So next state, and over here input is equal to 0 when input is equal to 1, and over here we have the output. So now see very carefully. If our present state is idle, so still write this 11011, okay. So if our present state is idle, okay, if our present state is idle, and if you get input 0, okay, if you get input as 0, so what will happen if input is 0? Look in the table also. If you are at idle, if you get input 0, your output will be 0 and you will remain at the idle state. So you will remain at idle out. And what about if input is 1? If your input is 1, you can see if you are at idle, if your input is 1, you will jump to S1. So write over here S1, and you have just achieved this bit, so output will be 0, okay, output will be 0. Now next case, if your present state is S1, okay, so here I will be doing every like 4, 5, 6. So S1, S11, S110, S1101, and last will be S11011. So you can see if your present state is S1 and if you get input as 0, so what will happen? You will be again going to see over here in this diagram. If you are at S1, this is your present state. If you get input as 0, so what will happen? You will go to idle in the next state. So write over here idle. If you are at S1 and if your input is 1, because I have made this for input 1, so this 2 sequence bit is completed, you will go to S2, but your output is still 0. Now next, if you are at S11 and if you get input 0, so this 3 bit will be completed, and you can see over here if you are at S11, if you get 0, you will go to S110 in the next state. And if you are at S11 and if your present state is at, means your input is 1, so where will you go? So look over here. If you are at S11, input is 1, you will stay at S11. Output is still 0. Now if you are at S110 and if you get 0, okay, if you are at S110, you get 0, you will go to idle. And after S110, if you get 1, so this state will be completed. So this you will be going to S1101 state, output is still 0. Now look, if you are at S110 and if you get 0 over here, input as 0, so once again you are going to move to idle case. Okay, look over here S110, and if you get 0, you are once again going to idle. And if you get 1, what will happen? You will go to S1101. So remember, this is your next state. If you give input, then only you are going to achieve. So here also your output will be 0. You haven't achieved the state yet. This will be the next state. So now when you have got the state, at that time, if you get input as 0, so look over here. if you get input as 0, so now look over here. If you get input as 0, so what is happening? If you get input as your 0, so you will go to S11. And over here, if you get 1, so you will be going to S11. This time your output is going to be 1 because this is your present state and this is your present output. So remember this always. Sir, you write S2, I think it will be S11. Where S2? Oh, sorry. S1. Yes. So is this clear? Tell me. Is this clear to all of you? So now basically you can even encode this as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Whichever way you want, you can encode it, and with the help of a D flip-flop, you can construct the sequence detector. Is that clear? Is that clear? So note it down very quickly. Note it down. Yeah, Piyush, you want to ask something?
Yes, sir.
Yes.
Can we make the same table with a slight difference? Like for the input 0, we are landing on, suppose we are starting, the present state is idle, and for input 0, we are again landing at idle. And for that also, we can write the output, corresponding output as 0. And again,
Yes.
if the output is 1, then for that also a separate column for a separate output column for S when the input is 1, it should be 0. Can we write two different output columns for 0 and 1
You
inputs?
can
Can we
write
make
it this way also. Look. So one more thing I am doing. So present state. Okay. Over here, I will be writing the input. Okay. And over here, the next state. What happened? I think, wait a minute. My computer got hanged. I don't know why. I don't know usually why this happens. Just give me a minute, okay? So this is the next state. This will be the output. Okay. So your present state, it can be like, so what all combinations I can take. So present state and input. So now this will be very, very big. See how? There are in total QA, QB, QC. So we have seen that idle state, I have represented it 0, 0, 0. S1 state as 0, 0, 1. S11 as 0, 1, 0. S110 as 0, 1, 1. And S1101, it is as 1, 0, 0. And S11011, it is 1, 0, 1. So here you have QA, QB, QC and input. Okay, input you have. So how many total combinations will be there of QA, QB, QC and input? How many combinations will we have? 16. Very good. So we will start from 0, 0, 0, 0, 0, 0, 0, 1. So this will basically capture all the places. Now what about if your present state is 1, 1, 0? So this state or even this state, it is not required. So for all this, our next state is going to be don't care. So we will be putting don't care, and even you can fill this table completely. You will be getting QA plus QB plus QC plus in terms of QA, QB, QC and input. Okay. So you can draw the K map and you can get it. Is it clear, Piyush and Raju, both of you, how to draw? Actually, you can use this table also. So the next will be what? It will be 0, means if I want to fill, so this will be 0, 0, 1, 0. Next will be 0, 0, 1, 1. Next will be 0, 1, 0, 0. Next will be 0, 1, 0, 1. Like this, 0. This is 5, 6 we need. Okay. Then we will have 7. Like this, the complete thing will go on. Okay. Is it clear, everyone? Tell me. Is it clear? So like this, you can fill the whole table and you can make what? You can make your complete circuit diagram also. Is that clear? Is that clear, everyone? Fine. So now let us see what. So I told you there are basically two models. Okay, two model. The first model was Murray model. Now we have what? We have your Mealy model. Okay. So we have the Mealy model. So now in Mealy model, how do we actually make the tables over here? Okay. How do we do it? How do we do it? So what do you think? Where will be the change? Where do we have the change over here? Just give me a minute. I am getting one call. Yeah. So in Mealy model, how is it different from Murray model? So over here, basically your output, it is actually function of your present state as well as your input. Okay, present state as well as your input, your output is dependent on. Okay, so now let me show you, if you had to detect the overlap, sorry, the sequence. So same thing, this is remaining the same everywhere. How to detect the number of output, the number of ones in the output, this is same whether you construct it using Murray model or even using Mealy model, it will remain the same. Only thing is that the hardware will be a little bit different. So let me show you how. Okay, so over here, if we have this sequence 1 1 0 1 1, so the number of states, it is going to be the number of bits only. So the number of bits over here, they are 5. So the number of states are going to be 5. Now, if I want to name the state, okay, if I want to name the state, so the first state, okay, the first state, it is going to be idle. The second state is going to be S1. The third state is going to be S11. The fourth state is going to be S110. And the fifth state is going to be 1101. Okay. So there will be no sixth state where you have S11011. So that will not be present. Here we have only 5 states. Okay. In Mealy model, we will have 5 states. So now over here, how will it be different? Let me show you. Okay. Okay. So in Murray model, I didn't show you for, okay. What is happening here? So I didn't show you for overlapping, sorry, non-overlapping. I directly went to Millet model. Okay, so you should have told me, sir, you didn't draw for non-overlapping. So for non-overlapping, so once again we are coming back to Murray model, non-overlapping. Okay, non-overlapping sequence, how do we actually detect? So look over here now. So in non-overlapping, remember that once the sequence is detected, you cannot take the bit of the previous sequence. You cannot take it. So once again, you are going to start from idle. Start from idle. Okay. If you get this first one as your input, so you are going to move to S1 and your output will be 0. Now if you get the next one, you will move to S11, output will be 0. If you get a 0 as input, your output will be 0, but you will move to S110. Now next, if you get your input as 1, so you will move to S1101, but still you can see your output hasn't been detected, means your sequence hasn't been detected, so output will be 0. Next case is what? If you get one more 1 over here, so you will be getting S11011. Now your output is going to be 1 and you have generated the sequence. Okay, so you have completed the procedure for getting the sequence. Now look over here. So that is why you people remember that day when we had solved the question, I told you that you should always search for the path in which you get directly from the first state to the last state. If you remember that question of sequence detector. You can see. So we had started from, this was actually the idle state. So I told you, search for the input when you go from this state to this state directly. Okay. So it was coming out to be as, you can see input is 1, you go to this state. From here, if you take input 0, you go to this state. From here, if you get input 1, you go to this state and your output is 1. So the sequence was actually 101 over here. Okay, it was 101. So same thing we are doing over here also, but in this question, it was written to detect an overlapping sequence. Now, if this is non-overlapping, look how will it change basically. See, this is still your Murray model only, and in non-overlapping, see, now after this, you have achieved this sequence. Now it doesn't matter if you get the first one. If you get the first one, you are still not allowed to consider this last. So where will you go? Where do you think, where are you going to go? If you get the first one, where are you going to go? To the idle or to, means if you get the next bit as 1 after completing this sequence, you can see once again you are going to the first bit of the sequence. So after completing the sequence, if you get 1, you are going to S1, and this is the first bit of the sequence, your output will be 0. But after completing this sequence, if you get 0 over here, so 0 is not actually the sequence, means bit in the first bit of the sequence. So you will move to idle. Okay, so this is 0, this will be 0. Okay, so in the last case, if you see over here, when we got 1, we went to S11, and if we got 0, we went to over here. But over here, the difference is this only. Remaining everything will remain the same. Remaining every other place, it will remain the same. Only after the completion of the sequence, the state diagram will differ. See, if you are at idle, if you get 0, you will remain at 0, output will be 0. If you are at S1, if you get 0, so you will move to idle. Okay, you will move to idle, output is 0. If you are at S11 and if you get 0, sorry, if you get 1, so where will you move? If you get 1, so you are going to move to S1. Okay, if you get 1, you are going to move to S1. Now over here, if you are at S110, if you get 0, so you have to go to idle. Okay, so this will be 0, 1. Now if you are at 1, 0, okay, if you are, just wait a minute. Yeah, so it's okay. So if you are at 1101 and if you get a 0, so once again you have to move to idle only, because 0 is not there in the starting of the sequence. So this will be 0, 0. So remaining everything will remain the same. Only thing is that at this 2, at the end of the bit, this is getting different. Okay, is this clear? So what are you telling, Raju? Idle?
Hello.
Yes, tell me.
That transition from S110, when the input is 0, should the output be 0 or 1?
Where? S110. Yes, this one.
Yes, sir. Yes, sir. From this, if the input is 0,
Yes. 110. If you get 0, yeah. So, okay,
so
so I have
the
written 1, output is. So this will be 0. Yes. Okay. So this is the non-overlapping model. Okay, non-overlapping state diagram. For this also you can draw the state diagram. Okay, state table. Sorry, I am not drawing it anymore. Okay. So now I was talking about Mealy model. Okay, Mealy model I was talking. So in Mealy model, you can see what, that basically we have 5 number of states. One more state is not required over here. So basically, how do we actually construct the state diagram over here? So first, let me show you for overlapping case. Okay, overlapping case. So once again, we have this bit sequence. So if you are at idle, okay, so if you get the first one in your input, so you are going to go where? You are going to go to S1, output is 0. If you get after this input as 1, so the next state will be S11, output is 0. After this, if you get 0, so you will go to S110 state, output will be 0. After S110, if you get 1 in your input, you will be going to S1101, output is still 0. Now after this is overlapping case. Remember, if you get, remember, after 1101, if you get one more 1, if you get one more 1, so where do you think will you be going? So basically your sequence is completed now. Your sequence is completed. Okay, your sequence is completed. Now see over here very carefully. This sequence is completed. Now if I start the sequence from here, you can see this is not the sequence, desired sequence. If I start the bit position from here, 0, starting bit is 1, so this is not the sequence. If I start from this one, so this 2 can be the start of the next sequence. So from here, if I get 1 in your input, I will be moving to S11, and this time my output will be also 1, because already I have got what? I have got the complete sequence. So this is where is the difference in your Mealy model compared to your Moore model, that here we have actually one less state. Now you don't need to worry. How will you actually know if it is Mealy model or Moore model? It will be given to you in the question. Okay, it will be given to you in the question. See, now you got over here. So now we have completed the sequence. Now, if you see, if we had got 1101, the next state would have been 0. So where are you going to go? So if you start from here, this is not the sequence. If you start from here, not the sequence. Here, not the sequence. 0 is not the sequence. So that means if you get your input as 0 after this state, you have to move to idle and your output is also 0. Similarly, let us complete. If you are at idle, you get input 0. So you will stay at idle only. If you are at S1 and if you get 0, so once again you will be going back to idle only. Okay, if you are at S11 and if you get 1, if you are at S11 you get 1, so that means you have already 1 and once again you get 1. So this 2-bit can be taken as the starting of the next sequence. So you will remain at S11 only. Now if you are at S10 and the next bit, if you get 0, so 110 you already have. If you get the next bit as 0, so you cannot use it in the sequence. So you need to move where? You need to move to the idle. So this is 0, 0. Okay. So this is the complete state diagram for your Mealy model for your overlapping sequence detector. Tell me if this is clear to you guys or not. Is this clear? Is this clear? Raju, Piyush, Bhumika, why are you so late? Bhumika, why were you late? Means it's already 10 o'clock. So you had your office work or what? So now all of you guys, I want you to draw for non-overlapping. Okay. So severe power cut is going to affect India. Okay. Severe power cut. So was it due to means this rain or was it actually means told to you guys that there will be power cut? Was it pre-decided that there will be power cut? So now you have to draw for non-overlap. Okay, so I guess it was due to some other factors then. So now India is going to face a severe power issues. Okay, because there is shortage of coal. If you guys read about finance, if you follow finance news, then you might be knowing that India is going under this thing. Means we have a lot of inflation going on in the FMCG sector. Okay, so food and food grains and oil seeds, India is suffering from like 14.95% inflation, and in total if you see then 6.95% inflation. On top of that we have shortage of coal. Okay, we are very much deficit in coal. So states like Maharashtra and Tamil Nadu, I guess I was reading today only, so all those states there will be severe power shortage. Okay, so there will be like every day 2 to 3 hours or even 4 hours of power cut. So that is a major thing that is we are going to face now. It's okay. So draw for non-overlap. Bhumika, you have missed the part. Okay, so you have to once again study. Means we have to once again see the lectures of this one. See, here also the states are going to be the same. Okay, but only thing is that you have non-overlapping over here. Okay, non-overlapping. So okay, one question I will ask you, means if you guys go to the vegetable market, so what is the costliest vegetable that you are buying at the moment? What is the costliest vegetable if you guys are going? So you guys don't go then. So over here, if you know this drumstick, okay, drumstick. So that day I went and I asked for like drumstick. So in Gujarat there is lot of drumsticks. Okay, even this vegetable vendors, they give you for free if you take vegetable of more than 100 from them. So I told him, bhai, give me some free drumstick. Okay, so he told me, bhaiya, it's 350 rupees per kg, And I was like, what? 350 rupees kg. Okay, lemon is like 175 or I guess 150 rupees kg. So all those things means a very difficult time is coming now. Okay, so now for non-overlap. Okay, non-overlap we have. So once again we are going to start from idle. So if we get the input as 1, okay, if we get input as 1, we will move to S1 state, output is 0. If we get one more, if we are at S1, we get input 1, we will go to S11 state. If we get input 0, we will go to S110 state, output will be 0. If we get input 1, we will go to S1101, output will be 0. Okay, now see over here, if you get 1 over here, so already you have got this much sequence. Now if you get 1, okay, so your sequence will be completed, output will be equal to 1, but this is non-overlapping. So where are you going to go? Tell me now, tell me, in which state are you going to go when your input is 1, your output will be 1, but what will be the next state? So you have already achieved this much. Now your input is coming 1 over here. So your next state, your sequence will be completed, but what will be the next state then? Yes, very good. Once you complete this sequence, now as this is non-overlapping, you cannot use any of the bits for constructing, for detecting the new sequence. That means once you have completed this sequence, you once again need to start searching for the first one of the sequence. So for that, you have to go to idle state. Okay, you have to go to idle state. But if you have got like 101 and the next state was 0, okay, if the next state was 0, so where will you go? Where will you go? If you have like, if you get 0, then where will you go? Same, once again, if you get 0, so you can see this sequence is starting from 1, so you have to search for the first one. So even if you get 0, it doesn't matter, you have to start from idle only. Now let us complete. If you are at idle, if you get 0, so you will stay at idle only. If you are at S1, if you get remaining, all thing will be same. Okay, remaining everything will be same. If you are at S1, if you get 0, you will have to go to idle. If you are at S11 and if you get, see over here, if you are at S11, okay, and you get 1, so you can use this 2 1 for your sequence detector. Why? Because this 2 are 1, your sequence, complete sequence has not been detected. If this was 1011 and after this if you had got 1, you cannot use this 2 1. Why? Because your sequence has already been completed. But over in this case, you can see this is not the completion of sequence. You are at the midway of the sequence and you are getting 1. So now you can use this one for completion of sequence. So if you get 1, you are going to stay at S11, your output is going to be 0. If after 110 you get one more 0, you will be going to idle state. So now your state diagram is completed for the non-overlap case. Tell me if this is clear to you guys or not. So I thought means you guys are from computer science. So if it is asked, so it's okay. You should be knowing this. Means for EC electrical guys, you guys don't need to know any of this. Okay, whatever shortcut trick I told you, that is okay. But for computer science, I was reading few questions. There was actually Mealy model, Moore model. So you should be knowing basically what is happening. So that is why I told this thing. Okay, tell me if this is clear to you guys or not. This modeling, is it clear? Everyone tell me. So note it down quickly. Note it down. So then randomly you can take few sequences and you can construct the state diagram. So you can construct for this one. So these are the usual sequence that are asked in exam. First is 101, another is 1101. So all these sequences have been asked in the exam. Okay, so for all this two, construct the overlap and non-overlap, okay, using Murray model as well as Mealy model. Okay, so you have to construct this. This is your homework. Will you be able to do this or not? Is this clear? Is this clear? Tell me yes or no. So the questions I have actually means I will be framing the questions. Okay, so now we have this thing. So we are left with something of the combinational circuit. Okay, so combinational circuit we are left with. So it's okay, we can do one thing. Okay, we can take this session tomorrow. Okay, it's okay, or else there will be nothing left for tomorrow if we finish this, and there are only few questions over here, so we will be finishing in this like in 15-20 minutes, so it will not be that much helpful. So better thing is that let us take the class tomorrow, and in tomorrow's session we will be completing this, and we will be discussing about the sequence detector I told you for 101 and 1101. So this two you need to come making the state diagram, okay, using Murray model as well as Mealy model. Okay, so we are left with this topic only. So this is 15-20 minutes, not more than that. Decoder, 2x4 decoder, 3x8, then we have active low encoder, priority encoder, that's it. Okay, here I have to discuss with you this thing, tri-state buffer. What is tri-state buffer? So this will be over, and this question. Okay, nothing will be left then. Okay, so in tomorrow's session we will be completing this. So tomorrow we will start the session from 8:50 then. Okay, is that okay everyone? Tell me yes or no. So this Mealy-Murray model was left, I thought, means I was solving few questions from the side that Piyush gave me, and I saw that specifically there were terms, Murray model, Mealy model, FSM. So I thought it's okay that I will tell you about all this thing, because last year there were no students of CS, so I didn't discuss this topic at all. But this year there are few students, means you guys are from their CS only, so that is why I thought I will discuss about this. Okay, so are you guys practicing the question? Tell me now. So okay, I will be spending like 15 minutes with you guys now. So one by one, tell me, what is your current status? Okay, what all topics you guys have finished and what all topic is left for you guys? Tell me now. Yeah, so let us start from Raju. Okay, alphabetically. So Raju, tell me. Speak up. Okay, I don't want you guys to be typing. So tell me. I asked you to speak and you are typing. Okay, so Piyush, till the time. Okay, Raju, speak up if you can. So like mathematics is over. So where are you guys in mathematics? So your mathematics syllabus is not that big compared to EC electrical IN.
Hello.
So where are you? Yes, tell me, Piyush. So
Uh,
Raju, you can
in
type if there is some issue with you. Yeah.
For digital electronics, currently I have revised it till this counter. Which one? This actually till level triggered and edge triggered I have done, and after that I will again revise it. I'm
Okay. So
actually
any doubts you are facing while solving the question?
uh, no, Yet now I haven't watched because whatever you have taught with that, actually I'm able to solve questions. And after that, I'm also taking help from internet so that if there is some extra like tips, if I can get
Mhm.
for
Mhm.
you say about tricks. So I thought okay, I also get some tips like how to do this, how to do that. So there are alternative, when I get alternative solutions for only one solution, then that's very beneficial.
Yeah, so that is very beneficial. So that you will get more tips you will get when you start solving test series. Okay, test series.
Test series, I haven't actually taken any subscription or a purchase for that. But actually, there are a lot of questions available from the gates syllabus itself. They are giving in.
Yes, there are a lot of questions available. So I
Yes, sir.
have already told, even if you solve the previous year questions, so there are lot of questions. Okay.
Yes, sir. And these specifically, I have seen that for just now you mentioned that for CSE the questions are slightly different. Like they are specifically asking related to, even if it is not related to, like there are as for this digital electronics, we see sequence detector. But for EC and other branches, these type of sequence detection problems are not given in combination with sequential circuit. So that's what I have seen, that even in mathematics they might be asking some kind of crypto arithmetic problems.
Yes.
Yes, they
Some discrete,
even if it is
that is
not
actually
related to
discrete.
algebra.
Yes, discrete mathematics they are asking. Discrete kind of.
No, no,
Okay.
sir. In discrete mathematics, actually, there is one aptitude section. In aptitude
Okay.
section itself, they have asked crypto arithmetic questions.
Is it related to encryption? What
Yes,
is
sir.
this encryption?
Once or twice they have asked about that, transposition, or like very simple transpositions, if are like shifting A, B, C, D, and corresponding digits. If we shift, we can encrypt 543 as 654,
Okay,
something
okay,
like that.
okay, okay. Yes.
That kind of, that's actually transposition cipher, as what I remember, because it was told in algebra part, but actually they told that it is actually part of cryptarhythm.
Mm-hmm. Yeah, so
There were
syllabus is little bit different from EC electrical IN. Okay.
yes, sir. For there is aptitude is very general section, so I didn't expect that this kind of question will also ask. But actually, what they have done is what I have observed, that from each and every topic of the CSE, like cryptarhythm and database, they may be asking some kind of very simple concept questions, and
Yes,
they will be
yes, yes.
giving it in aptitude, and those areas even in maths they will be asking.
Yes. So where students are not actually expecting. Okay. So even I was watching your questions from this website. Okay. And I saw a lot of questions which I was not actually able to solve by seeing them. First, this question. Okay. There are few more questions I was seeing. Like this question, it is very simple. But in recent time, means I was watching one more website, Gate Overflow. So there also you guys have question. Okay, Gate Overflow, GQ or something, GO. So there I was watching questions. Few of the questions I was not actually able to understand only what they are asking. Okay. Then I had to look the solution for that. And then I got, okay, so they are asking a very simple thing. So basically what they are using the jargon of your this computer science. Okay, the specific terms that are used in computer science, they are asking that. Okay, now how can we know? Actually we are, means I am from EC electrical IN background. Okay, specifically from electrical and instrumentation background, so I don't know that much about CS. But it's okay, it's okay. This year I will see to everything, means if we are teaching computer science, so it's okay, I need to get all those things. Yeah. So Raju, tell me about you. I have a book, from that I am solving some problems from number some. Why some? Why not all? Boolean minimization, and also trying some discrete mathematics problem algorithm, engineering mathematics, DBMS, and C programming. See, at a means simultaneously you cannot focus on multiple issues. Okay, you cannot focus on multiple things. Remember this when you are studying. At max to take two subjects. Okay, two subjects you can take, not more than two subjects. Because if you are reading like DBMS also, then C programming also, you are actually channelizing your thought process in multiple ways. So better thing is take two subjects, not more than two subjects. And don't solve some of the question. Try to solve all the questions. Okay? Try to solve all the questions. Is that okay, Raju? And have you completed the previous all the lectures that I asked you? Okay, fine. So yes. So while solving questions of digital electronics, are you facing some kind of problem from some topic? Where? Tell me. Where are you facing the problem? See, I will be taking one test. Okay, live test. So I will inform you guys when. Okay, I will tell you that I am going to take live test. Live test will be, we will be like sitting in the class and I will be asking you questions, all of you. So you guys need to answer. We will be taking one poll and you will be telling me the answers in that. So I will be asking you randomly, any one of you to solve the question. Okay. So if you are not putting efforts, I will be getting to know when we have that test. Okay. So like this year, okay. So you might be thinking, see, when you are actually taking the questions, okay, you are taking the questions, and by reading the question, you are not able to solve. Okay, you are not able to solve. But the moment you turn the pages and you see the solution, just by looking in the first line of the solution, if you are able to know, okay, so this was actually they were asking. So if that is the case, that means you require practice. But if after looking in the solution also, if you are not able to understand the question, that means that is the problem of your concept. Then you need to come to me. For this, you need to come to me. For this, you have to practice yourself. Okay. So that means you have the adequate concept, adequate knowledge, but you haven't practiced. So that is why you are not able to understand the questions. Okay. So this is the case then. Did you guys understand this problem? Raju? So I will say work on that. Okay. Work on questions. I have already actually given you that books, okay, resources for EC electrical IN. So from that book, you guys practice and let me know if you are able to solve questions or not. And I will be framing myself few questions for you guys. So those will be the toughest level of questions. Okay, in means in gate exam they won't be asking that kind of question, but they might ask some part of those questions. Okay, so I am framing those questions. So give me some time, like 1 or 2 weeks, because it will take some time for me. Okay, so I will do that also, and randomly one day I will take one class, because we have buffer days also. Like on Mondays and Fridays we don't have class, so any one of the Monday or Friday I will take your class, and then we will solve those questions. Okay, is that clear? Is that okay? Fine then.